Hello, guys. Welcome to Ramta Solutions. Welcome to your organic molecules series. Today's lesson is on esters, and this is all you need to know about esters. So, how will we structure this video, or how are we structuring it? I'm going to begin this with a brief on what esters are, giving you few of some properties of esters. Then we proceed to the naming of esters, which will be different to how we've been naming our homologous series so far. Then, to do justice to this video, we concluded by having examples where we are drawing and naming structures of esters. So, without any waste of time, let's get into it. So, what are esters? We are saying that they are organic molecules with a carbonyl group bonded to a hydrogen or an alkyne and an oxygen bonded to another alkyl group. Okay, this is interesting. I want you guys to see this. Now, as you can see, this is the general formula of your ester. So this part here becomes what we call the longest chain. Okay, this part here becomes the longest chain. It can have hydrogen, okay, or an alkyl. Okay, it can have a hydrogen or an alkyl. Okay, and this part here will become an alkyl, which therefore it is in fact an alkyl substituent. Okay, it'll become an alkyl substituent of your ester. You're going to see this later. Remember, alkyl that's bonded to the oxygen will become the alkyl name of your molecule, and the alkyl bonded to the carbonyl will become the longest chain. Together with the carbonyl, they become the longest chain. Okay, good. So esters are made through the reaction of primary alcohols with a carboxylic acids. This reaction is what we call esterification, and it is in the presence of a sulphuric acid. Okay, it is in the presence of a sulphuric acid. Okay, so here we should be writing H2SO4. Okay, here we should be writing H2SO4 on top of this arrow because it is a catalyst. Okay, so what you're seeing here is that esterification, the products of esterification are an ester and water. Of course, water is the inorganic compound that will be formed, and the ester is the organic compound that is formed. Okay, good. So, I also think I will be giving you a brief on this later when we do examples. Don't worry, I will show you. Okay, so now let's look at this. When we look at esters, their suffix is OATE08. Okay, OATE08. And I don't want to really say the simplest, but let's just say the simplest is methylmethanoate. What does it mean? It means the alcohol is the methanol. Okay, here the alcohol is methanol, and the carboxylic is carboxylic acid. Okay, sorry. The carboxylic acid is methanoic acid. Okay, the carboxylic acid is methanoic acid. Okay, the carboxylic acid is methanoic acid. Okay, carboxylic acid is methanoic acid. Okay, then the general formula of your esters, these are the same as that of the carboxylic acid: CN, H2N, and O2. Okay, CnH 2N and O2. These are the same as that of carboxylic acids. Okay. Something about esters is this. Ooh, they are responsible for those beautiful scents of our flowers, our fruits, So they have pleasant odors. Okay, they have pleasant odors. That's the beauty of esters. So they are responsible for those beautiful flowers that you are seeing, right? They are responsible for them. And something about them is this. You will see the structure later. They they have boiling points higher than the hydrocarbons that we dealt with, but their boiling points and melting points are higher than all the organic molecules that we dealt with that have oxygen. Okay, so their boiling points are higher than aldehydes, ketones, and carboxylic acids. Remember, carboxylic acids of all the homologous series we dealt with have the highest boiling point. Right? So these ones, you can say for molecules of the same size, boiling point in terms of increasing temperatures, it'll be one. If esters, ketones, aldehydes, and carboxylic acids in that order. So carboxylic acids have the highest boiling point. All right? Oh yeah. Then to conclude this, these ones are slightly soluble in water. Please highlight slightly soluble in water. Now let's look at their uses. I mentioned something. There's something that I mentioned. I said to you, they are responsible for that beautiful smell of our flowers. Ladies, you like flowers. I guess it means you're addicted to esters. And for those that love fruits, that taste of your fruits, whichever fruit you can think of, I chose pineapples. Esters are responsible for that beautiful taste. And again, they can also be used as solvents. For example, this one is ethyl acetate, it's a solvent. Okay. In your perfumes, you spoke of scents. Your perfumes are also making use of esters. All right. And then your vegetable oil. The vegetable oil is also making use of esters. Remember, being it sunflower, olive, whatever vegetable oil, it's making use of esters. Okay. All right. Remember, guys, these are not the only uses. There's more, but these are the major ones that we can think of right now. Okay. But there's more. All right. Now let's get to naming them. You obviously, when we name our organic molecules, we use IUPAC system of naming compounds. All right. So this one will be slightly different. How? The carboxylic acid. Remember, esterification says you are reacting alcohol with a carboxylic acid. The carboxylic acid becomes the longest chain. The alcohol becomes the alkyl group of your molecule. Okay? And remember, the name ends with OATE, O8. Okay? The name ends with OATE, which is O8. Right? Now, let's then head to drawing the structures of esters. I'm no longer going to focus more attention on the alkyl group. By now, you know them by heart, right? By now, you know them by heart. So let's begin. So I'm gonna try ethylpropanoate. Okay, I'm gonna try ethylpropanoate. Okay, I'm gonna try ethylpropanoate. So ethylpropanoate, this part here says it's coming from the alcohol ethanol. Okay, and then this part here says it's coming from the carboxylic acid, which is propanoic acid. Okay, propanoic acid. And this, in the presence of a sulphuric acid, right? In the presence of a sulphuric acid, gives us what? This guy here and water. Okay, remember, you have sulphuric acid as a catalyst. So what is ethanol? the structure of ethanol, sorry, it is 2 carbons. So let me do this. F means 2. And then you have propanoic acid. Let me draw it here. Prop means 3. All right. Prop means 3. All right. And you have sulphuric acid as a catalyst. All right. So what is happening, guys? The OH of your carboxylic acid and the H from the hydroxyl combine, okay? They combine, they form, let me now show you, they form water, okay? They form water, okay? They form water. Come on, buddy. They form water, okay? And then this part, remember, is from the alcohol. It becomes alkyl group, so it'll be this. And the O, do you see the O that is left? And then what are you left with? Here you can see the O is left, and then when they combine, you are left with this carbonyl, and then it extends just like that. It extends just like that. Okay? Oops. It extends just like that, plus the O, the H and the HO, here are they form the water. So here are they are forming the water. Okay, they are forming the water. Now this molecule here is what we call, hold on, this molecule here is what we call ethylbutanoate. Propanoate. Remember prop 1, 2, 3. So this is ethylpropanoate. Ethyl, here is it. Propanoate, here is it. Okay, remember what I said? I said these guys, one part will be the alkyl, another part will, of course, become the longest chain of your molecule. Okay, now let's get to another one. Then we have, let's try this one here. Let me see. Let's draw this one here and name it. So I'm gonna try this one here and name it pedi tharo, oxygen, carbon, carbon. Let me just end them here. Let me make a carbonyl here. So remember what I said to you. The longest chain, the alkyl group that is bonded to the oxygen will become your alkyl of the molecule. And this alkyl has how many carbons? 3. 3 means prop. So this will become, what does it mean? This will become propyl, isn't it? This will become propyl. And this is your longest chain. All right? This is the longest chain. And this is your alkyl. So this alkyl has 3 carbons. Therefore, we call it propyl. What is the longest chain? The longest chain has 2 carbons. 2 is F. So this is propyl ethanoate. Okay, propyl ethanoate. So this is made from ethanol. All right, it's made from ethanol and propanol, not ethanol, propanol. It's made from propanol because it's 3 carbons, right? It's made from propanol, right? This is propanol, and this part here is ethanoic acid, right? This part here is coming from the carboxylic acid, which is the ethanoic acid, right? It's the ethanoic acid. Propanol and ethanoic acid, when they react in the presence of a sulphuric acid, they form propylethanoate and water, isn't it? You happy? Great stuff. Moving on. Now let's look at I'm gonna try condensed structural formula here. CH3 CH2 CH2C OO CH2 CH3. So what is this? C uh-huh, 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 uh-huh. Right? Let's see now. Do you see this? Oh yeah. Now let's check. This will become the longest chain. Can you see it? It'll become the longest chain. And this, it'll become the alkyl. So this longest chain is what we called 1, 2, 3, 4, is what we called butanoic acid, right? Is what we called butanoic acid. And this, we called it 1, 2, it's an alcohol, ethanol. Okay? Now, what is the name of this compound? This, remember, this becomes alkyl, and this becomes longest chain, right? This becomes the longest chain. So what is this? This therefore becomes ethylbutanoate. Okay, ethylbutanoate. Happy? This is ethylbutanoate. Happy? Now let's try last one. The last one, let's see now. The last one will be BD. And then oxygen, carbon, double bond with oxygen, and a hydrogen. So now look at this one. When you look at this one, what do you see? Alkyl group bonded to the oxygen becomes the alkyl substituent of the molecule, and the carbonyl becomes your longest chain. So what is this? This was your 1, 2 carbons. So it was your ethanol, so we will call it ethyl, and this is 1 carbon, and we will call it methane. Therefore the name is ethylmethanoate. Okay, the name will become ethylmethanoate. Okay, ethylmethanoate. Okay, ethylmethanoate. So this is how you name your esters. Okay, this is how you name your esters. We have come to the end of our lesson. Remember to get in touch with us. Visit our website www.ramtasolutions.co.za. And if you would like to get in touch with us on your favorite social media, the links to these social media platforms in the bottom, you can see them. The links will be given in the description of this video. And therefore, the next lesson, we will be talking isomers. Okay, we will be talking isomers. And with that being said, let us say asante, enkosi, rolibuwa. Thank you. And lastly, ra leboga bagaetsho. Bye bye.